Voyage into the Singularity. Unveiling the Hidden Forces of a Five-Fold Well. This journey begins with a fundamental challenge in spatial analysis. Can we understand the entire contents of a volume just by looking at the flow passing through its outer skin? By dissecting this flow into individual directions and applying the principles of flux, we uncover a hidden mathematical signature. This signature reveals that the space is governed by a specific field, a potential well, whose intensity is defined by the inverse of the distance from the center, scaled to an aggressive fifth power. The forbidden heart of the field. In our first exploration, we assume the volume we are measuring stays clear of the very center. In this safe zone, the field is smooth and predictable. However, a fascinating problem arises when we consider what happens if our volume swallows the center point, the origin, whole. At this exact spot, the field becomes singular, meaning its strength explodes toward negative infinity. Unlike the more common fields we see in nature, such as the standard inverse square laws of gravity or electricity, this power of 5 field is exceptionally violent. While a standard field remains mathematically manageable even at its source, this specific field grows so rapidly that if the center is included, the total sum of the field within that volume becomes infinite. It is a blow-up so powerful that our standard tools of measurement simply break down. Visualizing the invisible. To make sense of this mathematical abyss, we turn to a series of visual demonstrations. The Battle of the Fields. First, we compare the aggressive power of 5 field against the more common power of 3 field. Through animation, we see that while both head toward infinity at the center, the field from our problem drops away much faster. This visual proof confirms why our specific field causes a total collapse into infinity while others do not. The sliding sphere. Next, we observe a three-dimensional model where a spherical region drifts through the field. We treat the origin as a forbidden zone to be avoided. As the sphere moves closer to this central hole, its color shifts dynamically, glowing more intensely to reflect the deepening potential well. This shows that as long as we stay in the smooth regions, our measurements remain stable and finite. A new perspective in flatland. Finally, we move to a two-dimensional plane to see how geometry changes the rules. In this high-contrast world, an area moves across a vibrant heat map. With the help of tracking crosshairs and real-time intensity labels, we watch as the area enters the heat of the field. This highlights the delicate balance between the geometry of the space and the pull of the central singularity, providing a clear window into a world of infinite gradients. Through this progression from abstract theory to vivid animation, we see the true nature of the field, a smooth landscape of predictable flow that hides a heart of infinite intensity.